Hey, welcome to the new Stunt Rigging Toolbox Talk. It's the last day of 2024. It's New Year's Eve morning. I'm in the shop again. We've been working through the holidays because I'm kind of a Grinch when it comes to all that crap. Anyway, a couple of things. Thanks to everybody who's hung with us this far to watch this shit. This year is like 40 some odd of these silly videos of really pedantic OCD shit that you should know to make informed decisions. And remember, here's the takeaway, guys, is there's no single way to rig anything, but there's levels of risk you're going to assume, okay? That's the takeaway. So you can do whatever the fuck you want. There is best practice, there is manufacturer's recommendations, there are the limits of various objects we use, from span sets, polyester round slings. Span set is a actual company product name. Polyester round slings, to shackles, to pulleys, to the rope we use. And knowing the limits is kind of important, so you can make informed decisions on how you do shit. Our basic principle is knowing this. We try to keep things simple and build simple systems that you can layer. So if you need to do a complex rigging action, you start with the thing that will accomplish the basic functions and add to that for the foo-fa, for the frills. You don't just try to invent some complicated brute force or ignorance way of doing it, because the fact is you don't want to have to rely on weighing 140 kilos and having hands the size of fucking Frankenstein to operate something. You want something that's simple and elegant. It's like a Japanese philosophy. It's like simple shit done well. And you can layer these simple systems and have them function. So we've kind of gone through all of that, knowing our limits and all that. That's what this is all about. There's two kinds of riggers. There's the guys who do it because this is how we do it, which couldn't tell you what the forces are, have no idea of the numbers, and don't really have a clue. They just know it works. And then there's the opposite end of the spectrum, which I know every little piece, math, physics, and geometry, and I prefer to work smarter, not harder. It's a complete difference in philosophy. If you can't understand it by looking at it, then you've done something wrong. If you can't simplify it, color code your pull lines, and keep it all run like a wiring loom in the sky so that you can follow everything and know, if you've got a 4-point bridle on a camera and you don't know which one's right front, right rear, left rear, and you can't level the fucker because you haven't labeled stuff, then you've done something wrong. So running stuff in weird angles and just all over like spaghetti is not what we're about. We're very OCD when it comes to all that shit. Anyway, so if you've stuck with us this long, you kind of already know that. And it's not all about cool machines. It's about, we love descenders and we love ratchets and we love all of this, but it's knowing the right tool for the job, keeping it simple, straightforward, safe. It's about treating your performers with dignity, not just expecting them to all be wizards, because they aren't. It's not like we've got Cirque du Soleil people we work with on a daily basis, who are phenomenal athletes. The stunt guys that are phenomenal athletes are relatively few, and they usually end up doubling specific talent. And even then, it's more sometimes about physical appearance. So you have to learn to work with these things and try to make your performers comfortable and try to work with the limitations. It's all about assessing what you have to do and the best way to get there. Anyway, this is supposed to be a talk on anchors. We're going to talk about anchors to end the year because we've talked about a lot of shit: base stations, service loops, strengths of line, harnesses. We've gone through a lot of shit. But I've kind of ignored anchors. And in our business here on film, we are usually on set, usually on a stage, and we have access to a concrete floor. But I'm going to kind of go over all sorts of anchors. I've got the whiteboard behind me. I'll pick up on that in a second. But I'm going to talk about the angles for your anchors. And there are force multipliers. Look at any of the rigging books I endorse, J.O. Gliram, Delbert Hall. And you look at the angles on things, and they are force multipliers. So you have to realize that with your anchors. Errata guys, sprat guys, rope access guys go for bomb proof. They want 5-ton anchors, 10,000 pounds if you're in Imperial, for all their anchors. That's not always obtainable depending on where you are and what you're doing, or people will say it is without knowing the structural integrity of what they're dealing with. So there's some optimal anchor varieties, and there's a couple of books on this. I mean, if you are out in the field, sometimes you use all sorts of weird anchors. You don't have an easy way to deal with putting shit into the ground. So we use IBCs, which are a cubic meter of water. They're on these shitty little aluminum pallets with this shitty little cage around them, so you can't really rig to that, but you can use them as ballast to sit on your truss or to sit on steel plate that your truss is attached to. I've used them on historical buildings that were built in the 1600s on the retaining walls that actually hold the buildings up, not on the roofs, and put them on truss that's balanced on the vertical walls and had it all taken care of by an engineer, because that was the only way to anchor anything on the truss up on the roof to do these things, as an example. Or if you look there's a great book which in America is done by the Army Corps of Engineers. It's the United States Army Corps of Engineers, does a field expedient engineering handbook. And they have a whole chapter on anchors, and sometimes digging a trench and burying something like a big tree trunk or a giant chunk of something in a hole and filling it back up again with the span set coming out the top to hook to is the way you work. And an example of that would be we were on a very cool old building in Morocco and had tension high lines, and there's no way to these mud and daub buildings that you can anchor anything. So we had trusses pushing down and redirected the high lines over the tops of these trusses outside the buildings. And we actually just dug big trenches, and they actually call out an angle on the face so you can't pull them out. Wrapped trunks, dropped them in, span sets long up and out of the ground, refilled them, wet them down, and let them sit for a day. And they were bomb-proof. You couldn't pull them out if you tried. Even a backhoe couldn't get them out. So those become expedient. And the Army Corps of Engineers has a whole list of various anchors and things. One thing to note about anchors is if you put something in and you pull it vertically, it wants to pull out. If you put something in and you pull it at an angle, it's going to be working against the shear force of the actual item, i.e. the pin you've put in, the stake you've put in, the bolt you've put in, the tensile strength on that. And an example is like a 10 mil bolt's like a 10,000 pound or a 5 ton in shear kind of anchor bolt, if it's mounted correctly, like say in a piece of steel or a piece of concrete. So if you're pulling up, you're going against the threads. If you're pulling at an angle, you're going against the actual force of the steel. And there's plenty of charts on these things, and Hilti has charts and all of that. But you end up with you need to have your anchors at an angle, because I'm going to go to the whiteboard in just a second. But if you're pulling vertically on a threaded in, drilled in anchor, you're relying on what's holding it in the material, the integrity of the material, and the thread depth and penetration. So that's why if you're pulling vertically on anchors, a lot of people use glued in anchors. You put in the anchor, you glue it in. Hilti sells you all sorts of cool glue, and you're good to go. You have a hydrostatic tester. I have one, not that I use it that much, but on questionable things I will. And you hydrostatically pull vertically on these things to make sure they're in and what their load rating is. Like I said, anchors are important. We tend to forget about them. You'll put in your truss base station, and people will anchor it with one strap at both ends instead of one to each corner, which is 4. And they will anchor them vertically. They will put the pins in next to, or bolts in next to the truss, and just loop over them. Not the best way to go. You want them in an angle. If it's 1 foot or a 300 millimeter truss, you want the pins 300 millimeter out diagonally from the side. So you're at least at a 45-degree angle. So you're pulling in shear. Okay, you get the best. 45 degrees or less, you're in more shear. 45 degrees to vertical, you are in more vertical pullout. So you have to start looking at problems with your anchors. Anyway, like back to the Army Corps of Engineers handbook, they give you things about putting in tent stakes, long, bull pricks we call them, but long, stakes. You hammer them in with a sledgehammer, and they go in at angles. If you've ever seen how they're put in, they go in at angles against the force. And you always back them up with a secondary pin. These are all the best possible practice. I guess I'm going to start right here because I'm sitting down with bolts. We're on set and we have cement floors, some of which are dubious quality depending on the stages you're on, and some of which are amazing, super high pressure concrete. A couple of the things, the newer stages you have to be aware of is not going too deep so you don't punch through the slab. So 100 millimeters is normally the longest you can put an anchor in. And they have call-outs per square meter or per square yard or foot of how many anchors can be in the cement so it doesn't degrade the slab. And then they fill them with a special epoxy at the end. We used to just fill them ourselves, but now people have gotten real finicky about that. So we use a variety of anchors, and I'm going to go through them. In the old days, like in a lot of the old stages in LA and stuff, they have cement floors, but they layer over them with 1 inch or 3/4 inch plywood, CDX. And as the stage gets built, they layer it with ply. That way they staple and nail the sets down, because they're wood, to the ply, which all rests on the floor. And each show that comes in, once they strike the sets, they layer some new plywood on it and nail it down. And you'll get into some stages that have 2, 3, 4, 5 layers of plywood on them. And then they'll rip it all out and then they'll start all over again, but that's only occasionally. So there's the anchors for that. In plywood floors, we use, they call them in England, carriage bolts. We call them lag bolts. They're basically bolt-headed, coarse threaded screws. And this is just a 10 mil one. We use 12 mils, and you can go, depending on your stage, the depth you need. They're a good option for wood floors. You always back them up, but this is when it's really important, because you're in wood, to have things at an angle and have multiple backups. One of the things we use on stage and in stunts that really, it's not optimal, but we use them because they're handy and they're available, are these Petzl type anchors. And now these are designed to be mounted this way and pulled in a specific direction. They're rated at 2.2 kilonewton or 2 tons basically. But they are directional. So when you mount them on the floor, you should be pulling in the direction that they're oriented. And one thing people always do is they hammer them in bone tight and nail them down and then pull on them. And what happens is it either loosens or pulls, or if it doesn't pull, it waits until there's a load to reorient. These should always be at least able to swivel slightly to orient before you lock them down. When, let's say, you're putting them in on your truss, because I'm sure none of you, and I don't, measure exact 45-degree angles. Diagonals are pretty easy to see at the end of a piece of truss. You just go whoop, and it's 300 mil truss, so you put it out 300, 320 mil, drill your holes, put your anchors in, run a delta maillon through this, because you're going to run a ratchet strap through it, tie your truss down, and pin it. It's great, but 45-degree angle because you're pulling in this direction, okay? You don't want to pull these vertically. So mounting these to the floor and pulling them vertically is definitely not what these are designed for. We use them a lot, and I see a lot of people do that. When it comes to anchoring these, the lag bolts work fine, 12 mil lag bolts, and you'll pin them in, but I always put a backup. Some guys put them back to back, which means one's in the false direction and one's in the right direction. Plus you have 2 anchors right next to one another. That makes no sense. If you're gonna back these up, put another one out here farther and back it up to your line or your span set with another line. So if this pulls, you have a second one behind it. Because it gets separation from the holes you're drilling in the surface, meaning the wood, because if you pull something out of the wood, you're going to shred the wood around it, and that's going to carry through the fibers. If you pull it out of concrete, you've obviously done something heavy duty, and you've disturbed the slab, and it's probably going to crack or fuck the slab in that area. So you want to be away from your primary anchor. One of the problems with these is on a 12 mil, and they've got knobs on the back, so they don't want to spin. So that's why I say put them in almost tight, get them oriented and tight, and then nail them down, and then you're good. Because if you put them in funny, you're going to be pulling against them in 2 directions because you're trying to orient this to your load. And remember, they are directional. Okay, they function, they're good. We've got some new ones coming out that are a lot bigger and better and will hold up to a 15 mil bolt. And they're easier to work with and way stronger than these. We're in the final testing on them. They're stainless, but they aren't cheap. These are cheap as chips. They're like $2-3 a piece. You just have a few hundred of them in your kit and you just use them. The bolts cost more than these do. Now for bolts in cement, there's a couple of options. The climbers do these old school ones. They drill a hole with a hand drill, banging it in. Then they hammer this thing in, and then they thread it up, and it sucks this sleeve over the end. We call these redheads. It's a manufacturer in the States, but they're just expansion bolts. These are horrible for us in stunts. These are like a total no-go because once they're in, they function if you put them in correct. You use the right size hammer drill into the cement, but you're left with a stud sticking up. So you always got to cut them off, and that's a pain in the ass. So these are not optimal. They are strong. If you run a 12 mil, it will go through a 12 mil will go through a 12 mil anchor on a Petzl. The second type of anchor, which is good if you're putting things in and taking them out, but you have to be careful because they have to be clean, are these inserts, which you drill a hole and it has a small sleeve inside that you set with a punch, a long punch, and you sledge it down and it expands this anchor into the hole below the actual hole. These need to be fit very tight, and then you need to have the right length bolt. And then you thread these in. The nice part is when you take them out, this is left in the ground or in the slab, so that if you need to come back, you blow the hole out and you can thread back into it and put your anchor back in. Again, a 12 mil on this will go through a 12 mil Petzl anchor, okay? So you can do this and back them up. These are useful. Problem is, you're also leaving this in the slab, and if your facility doesn't like that, which a lot of them don't because they can't get the epoxy they use all the way in. It fills this, and this is left in the slab. But they're very strong, and you can look at the manufacturers. But all of these are anchors. You don't run them vertically. These you can glue in. Look in your Hilti book. It's obviously bathroom reading for myself and other people. But it's a good anchor, a viable anchor. And then we come to my favorites, which they've been out for years, are these concrete screws. These are very coarse threaded. You drill the right size hole and you impact drive these in, and they cut threads through the substrate, through the parent metal or through the parent cement, and they fix themselves in. These can be used with glue, and I do use them with glue, like if we're using K-rail, concrete K-rail, we'll glue them in and shoot them in and then wait till they set and pull test them. But these are optimal. This is 100 mil long, 12 mil. This is a serious anchor. This is definitely over 5 tons. And you can look at what the spec is depending on the bolt manufacturer, and that all depends on the steel that's used. It's stamped on the head. The problem with these, the 12 mil don't go through a 12 mil hole in a Petzl anchor. Okay, so what you end up needing to do is have other anchor plates to use that have bigger than that, because these fins, these threads are quite large. They extend out 2 mil on each side. So they are impact, you need a serious impact to put these in, and they lock in. And if you don't drill your hole right, you won't be able to get them in. You don't drill your hole right when they run them in. If it's too big, you'll run it out. There's a call out for these. These are optimal because you can take and drill your hole, blow the dust out of your hole, or vacuum it. Depends on the drill you have. My Hiltis have vacuums on them. And then drive this in with a super strong impact, and this will not pull out. These are the optimal screw for stage anchors on cement, especially good cement. Old stages have a lot of keys, a lot of gravel mixed in, a lot of matrix, so they can be problematic when drilling, and you'll know that because you hit large stones, and drills don't like to go through large stones. They tend to go around them, and they become problematic with these. So you got to know your cement. But that's 100 mil. That's as long as it's accepted. That's a 12 mil. And when that's in, you aren't getting that out 5, 6, 7 tons. Okay, and you always back it up if it's questionable. And that gets to be the point when you're talking about anchors, is knowing your loads. You have to have an idea ahead of time what your loads are, because if you don't, then you will not be in a strong enough situation. I mean, for a hand pole, having one of these as an anchor point or a clutch or something, or your truss, one of these on four corners of a truss, because there's four of them, you're going to be pretty solid. But on a high line, and we run tension high lines at a ton and a half of pressure on the line, so they're stiff and tight at the top. With a ton or so of pressure on a high line, when you put a 100-kilo person out in the middle of the span, it will pick up your 1-ton anchors. So you have to know what you're doing there and do the math, because remember, the angles are multipliers. So you get into more IBCs or more anchors or stronger anchors or more weight, depending on your situation. So it's just, I'm going to breeze over a lot of this because you got to know these forces ahead of time. You can't just assume that you've got a bomb-proof anchor. It's like, the classic errata, will it hold a car? Well, it depends on what angle the car's at. If it's pulling, in shear, it'll hold a car. But if it's pulling vertically, it'll pull the anchor out of the ground, kind of thing. You got to think about these things. And you have resources available to figure that out. There's, like, Department of Geology has specs on different kinds of soil. There's things for sandy soil even. So you're on the beach. They make these things called ducks. That you have a long pole, you attach them, you pound them in 1.5 meters, 2 meters down, and you set them. They turn sideways and they end up as a weird flat plate that's pulling all that flat surface against the weight of everything above it. And that's a viable anchor in loose soil because they have a known pullout value at known angles. So these are all important factors to know when you're doing anchors. Know your loads and plan your loads to handle what you need plus a catastrophic failure of what you're doing, meaning a worst case scenario. What if you slam an e-stop button? What is that value? Okay, what is the value of a complete fuck up on a gold tail where somebody stops dead? What is the value of somebody pulling that hard on a ratchet? What is your anchor? What are your weights looking at? Remember, angles are force multipliers. So if you're doing a high line and redirecting, your top anchor is going to see a shitload of weight, not only your bottom anchor. I've watched high lines picking up 1-ton IVCs, no problem. I've watched Manitous flip over when people think they have everything dialed in and they've got the mass set up vertically and they're pulling through it and think that load's down. And guess what? It's so much load it tips the Manitou over. These are all important factors to remember. Okay, you need to know your loads and plan for the worst case scenario. Now on stage, we're, like I said, working with cement floors, usually not Manitous. We're working with truss. We have multiple backups. I do my own anchor plates, which are 8mm steel with large holes in them. You can spread your plate with a bar in the middle so you can attach to it. So you're pulling on 4 anchors at once, or however many big a plate you want to make, 2, 4, 6, 8. And you can utilize these things as your anchor points. But remember, I'm going to go over here. Angle is important. You don't want to pull vertically on an implanted anchor. It is your worst case scenario. So always, even if you've redirected over a beam and come down, come at an angle to your anchor. So you have some form, 45 degrees or less. So you're putting things in shear. That's today's anchor talk, and know your all the parts of your system. All these things play into your system. Rigging isn't just point to point. You can't just say, oh, my rope's strong enough and then fuck up the pulleys, use some shitty nylon roller pulleys or use some shitty slings or every system. Basically, you look at your system and the weakest part of that system is what you start your rating from. So you got to know all of this, and it's a pain in the ass to learn it all, but that's part of doing this job, is to learn all those components. And the weakest link in your entire system, once you know that, then you can plan accordingly, okay? Then you plan what your rating of your system is. You plan how much force based on how much risk you want to assume. Is this a system that's going to function 1,000 times? Is this a multi-day? Is this a multi-week? Is this a permanent install? Is this a one-off? What's my design factor? Am I going to use 3 times the expected max force as my maximum? Am I going to use 5 times? Am I going to use, the old 10-to-1 doesn't apply. And if you look at the American Flight Performer Standards, you'll understand that there's a good paragraphs in it about how to calculate your maximum forces based on maximum events, not just the old, 10 times. Well, 10 times static sometimes doesn't make any difference. Good example, a gold tail drop. You'll generate 5 times static body weight usually as a max. So 100 kilos is 500 kilos, okay? But in a catastrophe, you're going to generate more than that. So if your point you're attached to, or your rope or your line or your piece in your system isn't good enough for at least 1,000 kilos 1 ton, which is only double your expected force, or 1,500 or 2,000 2 tons, then you start looking at your levels. At a 1 ton, you're only at a 2-to-1 design factor. At 1.5 tons, you're at a 3-to-1. At 2 tons, you're 4-to-1 of expected max. Okay, now that doesn't include catastrophic max. Okay, so you start adding it up and you see what your anchors need to be. If you're doing a high line, you've already stretched it to 1 ton. Look at your math on high lines that they're available online nowadays, but you can calculate how much force you're going to see with 100 kilos in the middle of a 50-foot span on a 1 ton tension high line. And then you're going to plan that. But that 100 kilos on a 1 ton high line, you're going to need a 10-ton anchor or more to even be in the ballpark. So you need to start looking at these things and how they interplay with what you're doing, okay? Let's do a quick look at the board to summarize, and then I'm going to sign off for this year and get back to work. We've been building a cool piece of stunt equipment. I built one before 10 years ago, and this one's the Gucci variety, so we've been deep in all of that. Hey, so we're at the whiteboard, my least favorite thing in the entire world. So here's just a graph chart. It shows your anchor point. It shows 100% vertical and 100% in shear, right? So here's 45. You get to this point, if you're pulling on your anchor, you're relying on the integrity of the metal or material that your anchor is made out of, as well as the substrate. And then once you get over that, you're relying more on the substrate that your anchor's into because it's going to pull out. So you always want to stay in this lower range of angles so you're pulling in shear so that you can use your material as an anchor, not just on the threads and the material that it's in. So think of this. This is 100% vertical. You want to glue your anchors in. If you're using a pin, say a tent stake outdoors, it's got to be put in at a very heavy angle, and this at vertical is still going to want to rip it out of the ground. So you need to come at an angle on your anchors, and I always say 45 or less. Okay, that's just what I try to do. This is an IBC. It's 1 ton, 1 metric ton. It comes on a shitty aluminum pallet. They're with a bird cage and stuff around it. They're a great anchor, but you got to figure out how to use this. Whether you set it on things, you could put scaff tube through it and try to pull it through. We put it in the middle with a span set and redirect the span sets out the sides. Okay, these will want to slide if they're on a concrete floor, so you need to have something that will keep them from sliding, i.e. a rubber mat or similar, and pull at an angle, and then you will not be just pulling vertically. You can't put long enough span sets to loop them to the top and clip in at the top and use them vertically. Then you're picking them up directly, but you will crush these aluminum cages doing that. So it helps to put a bar and a bit of either truss or scaffold tubing around it to make a cage. But that's a 1 ton anchor. Here's a picture of the trench. You dig a hole in the ground and you slope the front face so that your anchor sits here and then your span set comes up to here. It can't pull out through the undisturbed earth, and you pack in behind it. So now your angle of pull, even at vertical, you're trying to pull it through all of this. So these are bulletproof outdoors if you do them right. And this is from the Army Corps of Engineers. Tent stakes are very similar. You'll put a tent stake in at an angle. There's your tent stake. Everybody loves putting these in, especially since you drill holes like in streets and asphalt. and you spend fucking forever pounding on these things with a sledgehammer. I have actually a jackhammer. I use an electric jackhammer, and I have a cup that fits the heads of the pins. But you want to put them in an angle. So here, and your force is going to be directed 45 opposed to this pin. This pin should also, from the upper portion, have another pin put in. So it's backed up. Notice it's from the head, so you can't bow this over. If this pulls too hard, or if you're... I hit the fucking button. This is a drag. So here's your tent peg in. You know, this can be 1 meter long, and you beat the shit out of this thing with a sledgehammer or a impact or whatever, or an excavator. You put it in an angle. It's a 45-degree angle, if you notice, and you put your line at a 45 opposite to it. You back these up by attaching higher on it and coming down to a second one. That way, as this pulls, if this wants to bend, because this is only like 1 inch diameter, 25 mil or whatever, this is held back to a second point. So now you have a very stiff, this is in the ground, you know, 750 to 1,000 millimeters. And then you have this sticking up, so now you back it up. Okay, so it's all about the angles here, folks. You back things up on your anchors. That's tent stakes outdoors. This works also with the ducks. You put them in and you pull up your span set and you anchor again. It's the angle. Notice this is at a 45 and your backup's at a 45. Okay? So you just set yourself up for your anchors this way. Notice this is a 45 also. Okay? And your span set will come up here. And you anchor that and pull it this way. There's no way in God's green earth you're pulling this out of this hole or up, even if it reorients and tries to pull the span set here through the dirt, because this has been unpacked and repacked. You can't pull it out of this area. Okay, it won't come out. You will break your span set before that happens. So remember on anchors what your load's going to be, your angles of pull on your anchors. And if you're not sure, glue the fucker in. But we don't have time usually is the problem. So anchor choice and anchor plate choice on stages becomes important. That's why I use truss usually for a truss base station, or if it's individual point anchors in various places on the stage, I will have a plate, which I've made, that have large holes. They're usually 300 by 300, and I have double directional 10 mil steel with holes in 2 directions as a cross that are all welded to this plate. And that way I've spread 4 anchors over a 300 by 300 footprint, and I can run bolts into all these. And that works for any floor, whether it's wood, whether it's concrete, whatever. You just put the appropriate anchor in here and anchor it down, and now you've got an angle to pull against, and you always want to go at an angle. Okay, so that's how you work those. Just remember that this is your basic triangulation. Again, we talked about triangulation. And remember, everything has force multipliers. Your service loop is a force multiplier. If it's anchored to something, it better have the rating you need, because if you're putting 1,000 kilos of force into your line, and you have a service loop that's going to see 2,000 where it's anchored down to, okay, because it's doubling, all right? So these are things you need to pay attention to. And those are minimums, you know, that's what it really reads. So what's your design factor going to be? You need to start thinking about that and redirecting things so they come in at angles, and that way you're on shear strength. And I said, when I talked sitting down, was look at your shear strengths on bolts, look at your thread strengths, look at your catalogs of the hardware you buy. It's not about just getting cheap shit, it's about getting the right shit. So that way you can assume as much risk. I don't care how you do it, like I said, but remember, you're the one that's going to get pinned for it. So you'd best have a reason why you're doing stuff, not just that's the way we do it. And you need to know these numbers and know your materials, okay? So that's signing off for this new year, the last of 2024, and we'll be back to more OCD and weird stuff next year, and maybe we'll have some more videos of actual rigs and install and what their achievements are, and I'll go through some other things. But right now, back to the mill, the lathe, and finishing this project. All right? All right, have a safe New Year's Eve. Don't do anything stupid. I'm sure everybody will. I'm going to go home and do amateur hour sitting at home. All right? Take care.